Hello everyone. In this video, I will explain how to check the regularity of the language. For this, we have two methods. First is My-hill Nerode Theorem. The another one is pumping lemma. In this video, I will explain My-hill Nerode Theorem. For that, we should know what is the concept of indistinguishability of the strings. Indistinguishability of strings. Suppose there are two strings, string x and y in sigma stars, are said to be indistinguishable with respect to some language L if and only if for any string z in sigma star either xz and yz both are in the language L or they both are not in the language. Then only we will say x and y are indistinguishable. Try to understand this. Suppose you have two strings x and y that belongs to sigma stars. And we will check if they are indistinguishable with respect to L. We'll take some string z that also belongs to sigma star and we'll concatenate x with z and y with z. And if x, z and both y, z both are in the language, then we'll say that x and y are indistinguishable. Or if both of them are not in the language, then we say that they are indistinguishable with respect to the language. So note down one thing. If xz belongs to L and yz does not belong to L, or xz does not belong to language L and yz belongs to L, then x and y are distinguishable with respect to the language L. Now we'll see some example. Suppose I have this example L is equal to a raised to the power n for any n greater than equal to 0. It means we have sigma a comma b. Find out x and y that belongs to sigma star. Suppose x is b and the another string b square. These two strings we have to check whether they are indistinguishable with respect to L or not. What I will do, I'll take one string z that also belongs to sigma star. Suppose this z is a raised to the power 5. Now concatenate this z with x and y both. So find out x is z. We have xz b followed by e raised to the power 5 and yz, y is b square a raised to the power 5. We can clearly see that both xz and yz are not in the language a raised to the power n because this language has strings of this form null, a square, a cube and so on. So therefore xz, both xz and yz does not belong to the language L. Therefore, we say that x and y are indistinguishable. With respect to the language L. Now let me take any other example. X is b and y is a square. Remember both the strings x and y belongs to sigma star and we know that sigma is ab here. So take one z. Assume that this is, again take it a raised to the power 5. Concatenate with x. So xz will become b a raised to the power 5. What is yz here? Yz is a square followed by a raised to the power 5, that is a raised to the power 7. That belongs to the language, whereas this string b followed by a raised to the power 5 is not belonging to the language L. So we can clearly see that xz is in L, doesn't belong to xz. xz is not in the language L, whereas yz belongs to L. Therefore, x and y are distinguishable string. X and Y are distinguishable with respect to the language L. Take one more example, this. Take Z again, say a raised to the power 5. Xz is this. Yz is a square a raised to the power 5. So this is a raised to the power 8 that belongs to L. And this is a raised to the power 7 that also belongs to L. Both xz and yz belongs to L. So we say that yz belongs to L. Therefore, x and y are indistinguishable with respect to L. So for My-hill Nerode theorem, we should know the concept of indistinguishability, or say the two strings are distinguishable, then only we can find out whether the language is regular or non-regular. For that, we will see the definition of My-hill Nerode theorem. Here we have My-hill Nerode theorem. A language L over sigma is non-regular if and only if there is an infinite subset of sigma star whose strings are pairwise distinguishable with respect to language L. Let me take an example: a raised to the power n, b raised to the power m, where n is greater than equal to 0, m is greater than equal to 0, sigma is given as a and b. Now what we will do, we'll find some infinite subset. Let S is the subset of sigma star and S is e raised to the power n for some n greater than equal to 0. Take any two strings x and y. X is assumed a raised to the power k, that is length k. K is any integer. Y is a raised to the power m. M is again some positive integer, and k is not equal to m, means the length of length of x and length of y are not same. Take one more string z to be appended, that is to be concatenated with x and y. Xz, this z belongs to any sigma star. So z is taken as, assume I take z is equal to b raised to the power m, that is length of z and length of y are same. So now we start concatenating this x with z and y with z. X, z, I'll get a raised to the power k followed by b raised to the power m. Yz is a raised to the power m, b raised to the power m. We can clearly see that both of these strings belongs to the language, as the language says that any number of a followed by any number of b's. So therefore, any number, these both xz and yz, both of these are there in the language. That is, we can see that since x and y are indistinguishable with respect to a language, therefore this language is regular. It is not non-regular, it is a regular language. So L is regular. We will say the language is non-regular if the strings x and y are distinguishable with respect to the language. Now see this example. It says that language L is e raised to the power n, b raised to the power n for n greater than 0. It is a language over an alphabet. Sigma is a, comma b, and we need to prove that L is non-regular using My-hill Nerode theorem. What we need to do, find out the sum S subset of sigma star infinite subset. So assume that S is a raised to the power n for n greater than 0. Now take some string x that is belongs to this S, another string y that also belongs to S. Suppose I take x is e raised to the power k and y is e raised to the power m. Well, k and m are some positive integers and they are not same. Means length of x and length of y are different. Take one more string z that belongs to sigma star, and suppose I take z is equal to b raised to the power m. Now concatenate x with z, concatenate y with z. If I concatenate x with z, I'll get a raised to the power k followed by b raised to the power m. Y with z, a raised to the power m, b raised to the power m. Now we can see that this a raised to the power k, b raised to the power m is not in the language L because number of a's and number of b's are different. The language L says that both the a's and number of a and number of b's should be same. YZ, in case of this belongs to the language L as number of a's and number of b's are same. So we see that XZ does not belong to L, whereas YZ belongs to L. Therefore, X and Y are distinguishable. If they are distinguishable, it means that the language is distinguishable with respect to L. Therefore, L is non-regular. Now it is a non-regular language. It means we do not have any finite automata accepting it. Here in this example, L is equal to WW, such that W belongs to 0, 1 clean closure. We need to prove that L is non-regular using My-hill Nerode Theorem. So what type of string L has? Suppose W is 0, 1, 1. So the language has a string of this type 0, 1, 1 followed by 0, 1, 1. Or say 0, 1, 0, 1, or say 1, 0, 1, 0, or say 1, 1 followed by 1, 1, and so on. So what we need to prove this, so we need to find out the subset, any infinite subset S that belongs to sigma star. Let S is equal to 0 raised to the power n for any n greater than 0. And we need to find out the two strings x and y that belongs to S. So suppose if I take x is equal to x belongs to S and y belongs to S. Suppose if I take x is equal to 0 raised to the power n and y belongs to 0 raised to the power m for some n m not equal to one another. Take some string z that belongs to sigma star. Assume that I take z is equal to 1 raised to the power n followed by 0 raised to the power n followed by 1 raised to the power n. Now concatenate x with z and x with y, y with z, x with z and y with z. I'll see that x is 0 raised to the power n, z is 1 raised to the power n, 0 raised to the power n, 1 raised to the power n, and y is 0 raised to the power m followed by z, that is 1 raised to the power n, 0 raised to the power n, 1 raised to the power n. We can clearly see that xz belongs to the language L, whereas this yz is not belonging to the L. So therefore, I can say that x and y are distinguishable with respect to the language. Distinguishable, since they are distinguishable, x and y are distinguishable with respect to L. Therefore, the language L is non-regular. So we have proved the non-regularity of L by proving that the two strings X and Y are distinguishable with respect to the language L. Now take one more example. Suppose I have this language which has balanced parentheses. Open parenthesis raised to the power m, number of parentheses has to be same for every string in the language L. So start with finding the sum subset, infinite subset of sigma star. We can clearly see what is sigma star. Sigma is open parenthesis and close parenthesis. There are two symbols in this set. So we find out this S. Assume that I take this as closing parenthesis or say opening parenthesis raised to the power n for some n greater than equal to 0. Take out the two strings X and Y from S. This is K, this is M for some K and M are the two positive integers K and M are not equal to one another. That is, these two are different integers. Find out some Z that belongs to sigma star. Suppose I take this as Z is closing parenthesis raised to the power M. M is any positive integer. Now concatenate X with Z, Y with Z, X with Z and Y with Z. This will result in open parenthesis raised to the power K followed by closing parenthesis raised to the power M. And this is opening parenthesis raised to the power M, closing parenthesis raised to the power M. Now we can clearly see this is not in the language L, whereas this belongs to L. So therefore X and Y are distinguishable. Therefore X and Y are distinguishable with respect to L. Therefore we say that the language is non-regular. I hope the concept of finding the non-regularity of the language using My-hill Nerode theorem is clear to all of you. The only aim, try to find out the distinguishability of the string. For that, I will repeat the process. First of all, in the language, find out seeing the language, find out the sigma. See the sigma, what are the symbol? Based on that sigma, find out the infinite subset of that sigma and then take out two strings from that set. That is, in this case, we can see that this is infinite subset of sigma subset. From this subset, take out the string X, take out the string Y and then take some string Z. Remember that this Z belongs to sigma star, that is any string from the sigma star. And then perform the concatenation operation. If one string xz is in L or yz is in L but xz is not in L, then we say that x and y are distinguishable with respect to L. If both xz and yz are in L or both xz and yz are not in L, we say that these two strings are indistinguishable with respect to L. In that case, we cannot prove that L is non-regular. We'll say that the language L is regular. So I hope the concepts are clear. Thank you so much for watching the lecture.